dealing with line segments, okay? We're dealing with coordinates. For those who don't know, when we're dealing with a coordinate, it's a point on your Cartesian plane, right? Your Cartesian plane is your x-axis and your y-axis. Your y-axis is the vertical axis, right? And your x-axis would be the horizontal axis. You ever see these things before, bro? X and Y, right? Proper thing, right? Okay? So, a coordinate is a point on this plane, right, Shana? So, if we're dealing with -5, 6, -5 will be your value on the x-axis, and 6 will be my value on the y-axis. Hi, Miriam. Right? So, same thing for D. D, your x-axis value is 7. Your y-axis value is 2. Everybody good there? So if you plot in this point, -5 on the x-axis, I just do now a rough sketch of where it might be. -5 might be somewhere quite on the side, right? So 0 is in the middle here, okay? So it's like a number line. So like on this side, you'll have -1 going down the road until -5 might be somewhere quite down here. Cool? So -5 on the x-axis will be here, and then +6 on the y will be somewhere up here. Right, bro? So that point, let me just move this here. That coordinate will be somewhere like where the two intersecting. Miriam, you wasn't in class last week online? Yeah, it was. All right, good. So this coordinate will be like somewhere here, where the 2 points meet. So this will be C. You see that here, bro? -5, it's in line with -5, and it's in line with 6. Cool? That's your coordinate, -5, 6. Everybody good there? And then 7 on the x-axis will be like somewhere quite up here, right? Because you're coming 1, 2, 3, 4, 5, 6, 7 going up the road, right? And then 2 on the y-axis will be somewhere here, right? So 7 and 2 would be where 7 and 2 meet. D would be somewhere here. You good there, bro? Right? So D, this is 7, 2. That's our crash course on how to plot a point. Tristan, talk to me. You good there? So if I join these 2 points, right? If I join here, boom, bang, right? That's your line segment. Everybody good there? Miriam, you good there? You know how to plot your points, right? Everybody had it? I wonder if we're using graph paper today. Any questions, Lord? I'm not sure, you know. I'm not sure if we're using it. But you all please make sure you always have graph paper. Right? Everybody good there? That's your line segment. So when I talk about the midpoint of this line, what midpoint mean? If we talk about midway between Tristan and I, and you talk about halfway between, so a midpoint will actually be a point between C and D, and we call this point like capital M. Okay, that's your midpoint. So we want to find out what is the X value for this and what is the Y value for this. That's what the first part of the question is asking you. Calculate the midpoint of the line segment CD, right? We have a formula for this. So what we do when we have 2 coordinates, right? So I just write it in red. You'll write it over if you note. I don't care if you note, write it over, right? Note. So if I've given, so you all can write same speed with me, so I wouldn't have to wait, right? So given 2 coordinates, so given 2 coordinates, first one will be x. Now the little 1 here, that means x from the first coordinate, comma, y from the first coordinate, right? And so you have x1 and y1. And then you have, says 1. Then you have x2, comma, y2, right? Okay? The midpoint would be equal to x1, meaning x from the first coordinate plus x2, x from the second coordinate, all over 2. You divide it by 2. Then you have a comma, y1 plus y2 over 2. Everybody good here? Right? So it's like you're working to find out what the midpoint is. Tristan, what is the value of x in your first coordinate above there, which is C? What's the value of x? You see that? C. You're looking at C. What is the value of x to C? -5, food. Right? The maximum newcomer. Let me see if you understand what I say. What's the value of x in the second coordinate, which is D? Remember, telling the x value is the first number and the y value is the second number, right? So look at the coordinate D. What is the x value in D? Right, perfect. 7, right? Okay, and then divide by 2. So we're talking about what I'm going to put a little x1 above here, and I'm going to put a little y1 here. Everybody good? And then I'm going to put a little x1 here, and I'm going to put a little y1 here. No, sorry, 2. Very good. X2, Y2. Okay? Everybody good there? Come on, Miriam. What's the value of y in the first coordinate? The value of y in C. So you're looking at C. C is the first coordinate, right? What? 6. Perfect. Plus, what's the value of y in the second coordinate? In the second coordinate, which is D. What's the value of y? 2. Perfect. Right? All over 2. So when you work this out now, you will get what your midpoint is. Everybody good here? This is the easiest thing in everything in coordinate geometry, the midpoint, right? So what we get here? Yeah, scientific calculator, bro. Right. So you could do -5 plus 7. What you get? -5 plus 7. 2. 2 divided by 2 is? 1. Comma. 6 plus 2 is? 8 divided by 2 is? 4. So my midpoint, which is capital M, would be 1,4. Right? Ask the questions or let her ask now. Teaching now on pause it. I do that this morning too. Right, so there we go. So we want the gradient of the line segment CD. Gradient. From the time you hear gradient, think of a hill. Right? The gradient is how steep the hill is. Right? Look at that line. You see how that line going down so? Right? That the gradient is how steep that line is, how much it is bent. Okay. Now, when the gradient is going that way, who could tell me if it's negative or if it's positive? Negative. We did that last day, right? So the newcomers will know that. But last day, wait. That's not right. Look at it, right? So if your line going up, it implies a positive gradient. If your line is coming down, it implies a negative gradient, right? Take a screenshot with your eye, right? Okay, so that is what it is there. Bro, here what I do. I send this in the group after, copy down all these notes, right? This evening. It don't matter that you have it on your phone, still write it over. When you write over, things internalize when you're writing, right? I'm preaching that to this trend about 2 years now, right? But you now coming, so I had to tell you, right? So there we go. So we want the gradient of the line segment. Once again, we have a formula. Okay, so gradient is represented by common M. Everybody get there? Capital M is? Common M is? Right, so gradient is equal to y2 minus y1 over x2 minus x1. But Daryl, I just tell earlier that x1 and y1 is the x value and the y value in the first coordinate, and the x2 and y2 is the x value and y value in the second coordinate. Remember I just said that? So let's work. y2 minus y1, right? What is y2 here? Anybody? What is y2? 2. What is y1? Oh, let's see that. Daryl, you see that? y2. Look, y2 here. 2, right? y2 is 2. Now, it really helps to parallel x1 and a y1 over what it is, right, Shania? And you put x2 and a y2 over what it is, right? So that you have it for all the other parts. Cool? Once you start your question, try to practice this. Always practice this, right? So y2 is 2, y1 is 6. Let me pump that in our formula, right? So come on, pump it in. So this will be equal to 2 minus 6 over what is x2? 7 minus negative 5, right? So to be 7 minus x1 is negative 5, right? I should do this already, Daryl. A negative and a negative is a boom. So this will be 7 plus 5, right? Okay, so this will be equal to 2 minus 6 is divided by 7 plus 5, 12, right? Now, once you're doing gradients and all these things, please leave my answer. So leave gradient as a fraction. Please, this is very important, right? Everything I write in red, you'll write in red also, please. Right? So let's break it down to be what? Negative 1/3. 4 into 4, 1. 4 into 12 would be 3. Right? Negative 1/3 is the gradient of my line segment CD. Remember, now tell her if we're going this way is a negative gradient. So you see how it's negative? Miriam, you see how it's negative? Once it go now is negative. All you write out, if all you don't have any notes, write it out, please. Right? So write down that quick. Right? So I'll go through it one more time. What is a perpendicular bisector? It's a line that cuts our given line in half. It passes through and it forms a 90-degree angle, right? Passes through the midpoint, forms a 90-degree angle. Everybody clear here? I see Daryl writing it down, so let me leave it for him to write it down. As a matter of fact, everybody write it over. Write it again. So a refresher on what this means to our gradient, right? So this was the note from last day. We said that the gradient of the perpendicular line is the negative inverse, right? So if the gradient of the original line is m, it will be the gradient of your perpendicular line will be 1 over m multiplied by -1, right? So let's write what's in red. Only what is in red. Write it over. What is in red? Question. Anytime I see I press pause on pause. That's remind me now. Anytime I do. Right, let go. Scrolling back down to the question we are currently doing, right? So they want us to determine the equation of the perpendicular bisector. So I now told you all what needs to be done to find the gradient of the perpendicular bisector. The original gradient was what? Look, it's right there. The original gradient was -1/3. So if I want the gradient of the perpendicular bisector, which is a new gradient, you have to flip it. So it becomes -3/1. The negative doesn't go away as yet, right? And multiply it by -1. Everybody good there? Flip it, multiply by -1. So the gradient of my perpendicular bisector, which is a new gradient, will just be 3, right? -3/1 multiplied by -1 will give you +3, right? Then, in order to find the equation, they want the equation of the perpendicular bisector, right? So in order to find the equation of a line, you must have the gradient and you must have a point on the line. Now the perpendicular bisector passes through perpendicular bisector passes through we just find the midpoint. What was the midpoint? Come on, 1, comma. Are you with me? What is the formula to find the form for the equation of a line? Proper thing. Y minus, stick them thing in all the brain somewhere now. Y minus y1 is equal to m, open brackets, x minus x1. And we work this down so that it will be y is equal to mx plus c. Right? Watch it. I want to put a little x1 here, and I want to put a little y1 here. Just so I know what is x1, just so I know what is y1. Everybody with me? Right? So we plug it in. You're not plugging in any value for y, you're not plugging in any value for x, right? That remains as y and x. So I'm going to put y minus, what is x? What is y1? 4, boom. Miriam, you with me? What is gradient? What is common m? 3. Shania, you good? Too much, too fast? Are we good? Pace good? Shania, what is x1? Look x1 up in the corner there. I put a little x1 over it. 1, right? So I need to get rid of these brackets, right? So what am I multiplying 3 by? By x alone? Boom. Let's go, right? So, hey, remember last day I was saying, let me fling this -40 one time, flinging a negative 4 there. So y alone remains on this side. Okay? 3 by x would be? 3 by negative 1 will be? Negative 4 becomes? Ooh, that'll give me chills. So y is equal to 3x, negative 3 plus 4 is? Positive 1. This is the equation of my line. The equation of our line is in the form y is equal to mx plus c. Y is equal to mx plus c. Right? Remember what c was? Y-intercept. It's just where the line cutting through the y-axis. So c is your y-intercept. All them notes are above it, Daryl. So copy it when you go home this evening, right? Copy it over. Everybody good here? Equation of a line. Oh, buddy, not supposed to be getting no problem with this. All right, bros. Right. So let's read the question. Let's assess the question, right? Another line AB is parallel to CD. So I'm scrolling up to the little drawing I just did, right? Another line AB is parallel to CD, right? What does parallel mean again? Anybody could remind me? Running side by side and they never meet. They never touch, they never meet. Okay, so let's go and draw a little line here, right? I'm gonna move this on. Yes, I want to move this to here, right? Right. So let's draw our next line here. I'm gonna put same right. So they say another line CD, no, not CD, I think it's AB. Right. So another line AB runs side by side. Right, let me go down and see the question. Right, another line AB is parallel to CD and passes through the point 0, 1. 0, 1 means 0 on what axis? And 1 on the, everybody good there? XY, right? So 0 on the X, 1 on the Y. So I'll scroll it back up, right? So they want us to write down the equation of the line AB, but let me get all the facts right first, right? Which is we need the gradient and we need a point on the line. CXC gave us the point on the line. Everybody cool there? CXC gave us this coordinate already. So let me go. Right. Two lines are parallel. You can indicate parallel lines by just putting 2 arrows, right? Now the thing about parallel lines is the two gradients are the same. If two lines running side by side, so any steepness of this line is going to be the steepness of the next line. That's common sense, right? If the line is so, same thing. Or anyhow you turn those lines, the gradients would be the same. Everybody good there? Shania, you good there? The gradients are the same. Shania, you ain't looking like you here. Try to lock in, sister. Try to lock in. M is equal to, what was M for this one? I think it was negative a third, right? The gradient of the original line was negative a third, which means the gradient of the parallel line is negative a third also. So I have my gradient. Everybody good there? Scroll the mark down. Right. So the two things necessary to find the equation of the line is you must have the gradient and you must have a point on the line. CXC gave us the point on the line. Right? So I'm going to put a letter X here, X1, and I'm going to put a letter Y1. Shania, what's the formula to find the form for the equation of a line, Shania? Shania. Let me go. Y, look at right here, Shana. Watch. Look at it right here. See that? Look how pointing it. Y minus Y1 is equal to M open brackets X minus X1. Everybody good there? We good there? Scroll back down. I'm going to write out my formula. What is that again? Y minus is equal to, we good there? Formula to find the form. What's the form for the equation of a line? What's the form for the equation of a line? Y is equal to mx plus c. What's the formula to find the form? That is the formula to find the form. Right? Well, I wrap this wrong on the head, eh? Am I going too fast? Good pace? Shana, you hear sister? All right, there we go. We're good. Shana, what? You going to do this one, eh, Shana? Y minus what? What is Y1 here? Just write down the coordinate. What is Y1, Shana? Look at the coordinate here. 1. What is M? negative 1/3, right? X minus what is x1? Everything right there, right, sister? Just had to get ahead in it, right? So we good there. What we had to get rid of now? We had to get rid of the, let's go. This by this, and this by this. We flinging the negative 1 on that side one time, right? Okay? All you remember that when they're doing this in the classroom, you know, say, sir, say to fling that one day, right? Y is equal to negative 1 by x will be negative 1/3. I say negative 1. Negative 1/3 by x is negative 1/3 x. Everybody good there? Negative 1/3 by 0. Anything multiplied by 0 is, so I'm not even going to put that. That dead, that gone, right? But the negative 1 had to come on this side. Negative 1 becomes, let's go. That's it there. There's nothing else to do. That's the equation on my line. Let me just write this out a little better. Right? Plus 1. Proper thing, guys. Those who are the right, and I forget to put it. But that's one thing. Let go. All right. Right, let go. All right. I want to make this a little bigger. Just I want to move this, the whole thing. Huh? Oh, this is it? Right. There we go. Oh, let's see the two lines. Who could tell me what's going on with line 1 and line 2? What they are? They are what? Parallel. Everybody see that, right? Right. This line is actually vertical. Not vertical, sorry, horizontal with the x-axis. You're seeing that, right? Now, look at this up here. The diagram below shows the graph of 3 straight lines, right? 3 straight lines we have here, right? So y is equal to 2, y is equal to x, and y is equal to x plus 2. State the correct equation of each of the following lines. So we actually have to figure out what is the equation of each one of these lines, right? Now the line where y is equal to 2 means it's going through where y is 2, and every single point on that line, y will be equal to 2. Who could guess which line that is? 1, 2, or 3? It's going through where y is 2. Look, he done put it up already. Watch, y'all seen 2 here? This is 2, right? Look, 2. I don't know if it wasn't seen it properly. That's 2, right? So this line is actually going where y is equal to 2. So straight off the back, you know this is y is equal to 2, right? Let me write that here. Line 3. This could be problems. Hold on, Right, we're catching meta here now. Right, so we say this one here would be y is equal to 2. Right, so that one, we use up this one, right? That's the equation of that line. That equation is simply y is equal to 2, meaning that the gradient is 0. Once you have a vertical line, sorry, a horizontal line or a vertical line, the gradient of those lines would be 0. I should put that as a note. Let us put that as a note. Right? In red, note the gradient of a vertical or horizontal is 0. Everybody good there? The gradient of a vertical line or a horizontal line is 0. So that means if it's y is equal to mx plus c, if m is 0, and we'll never have nothing x, because 0 multiplied by whatever x is would be 0. So it'll always be like y is equal to 2, or like if it's a line going through x, it'll be like x is equal to 4, right? Everybody catch me there? Vertical or horizontal line, the gradient is always 0. Right, let me rule. Now, we have the line y is equal to x, meaning that on that line, every coordinate of y is the same coordinate as x, right? So I go and look at this point here. What's the coordinates of this point right here? 0, 0. The value of y is the value of x, meaning that y is equal to x. And if we just hint and look at, you can gauge it, watch it. Look at this, where this coordinate will be here, our coordinate on this line. What's the coordinates of this point here? 1, 1. And y is equal to x. Shania, y is equal to x. You sure? All right. So the line 2 would be y is equal to x. You all see how I get that? That's the gradient of that line. Y is equal to x. What's the not the gradient, sorry, the equation. What's the gradient of this line? Y is equal to x. If I just write y is equal to x, what's the gradient of this line? Who somebody said? 1. Y is equal to mx plus c. Watch it. What numbers understood in front x here? Boom, 1. So m is 1. Our c is
0.
C is 0. Watch it here. And it passing through 0. And it passing the y-axis at 0. Right? So this is really the equation here. But you don't have to write all this back and all. You can just put y is equal to x. Cool? Yeah, that's right. Y is equal to x. This actually means all of this here. Near you here? Right. Lucky, no? Right. So obviously the last one will be what? Obviously the last one will be y is equal to x plus 2. Let me look at it. What's the gradient of this line? 1. Where does this line cut the y-axis? 2. And they cut the y-axis through 2. Hey, what's that called? Geometry is beautiful, you know. It's a beautiful topic, you know. What's that? All of them. I like bearings, eh? I love bearings. Let me go. Yeah, true. Let me go. So this one will be y is equal to x plus 2. All right, now here. Now this question, I don't know why I put on this worksheet, but this question actually have some linear programming in it. But we're gonna look at it one time. That's where the region in here, I'll show you going to access to the inequalities that represent this region. I'll show it one time, but we have a whole, I think I'll actually put this question on that worksheet. I have a whole worksheet on linear programming, right? So there we go. Show that the gradient of line 1 is equal to 1. I just school all learn that, right? Show that the gradient of line 1 is 1. Now, I show it from the equation, but if you have to show it here, you actually have to do m is equal to y2 minus y1 over x2 minus x1. Now, line 2 was which line? Y is equal to x. So, any two coordinates on that line. Give me two coordinates on that line. Any two. 0, 0, 1, and 1. Oh, you see the heights here? It's not really heights, you know, it's beautiful. It's a beautiful topic. And bro, and you like this topic already? Daryl was he say this man mad boy. Right. There we go. All you understand how I get them two coordinates? Y is equal to x. I could have put 10 and 10. I could put 11 and 11. Let me use 11 and 11. Because any value of y will be equal to x. Right? Right, Keegan?
Yes, sir.
I can use any two coordinates. Any two. Right? So the mere fact that they want us to show this, I can't just put y is equal to x and then say, well, the number in front x is 1. We had to shoot. So we get two coordinates, right? So x1, y1, x2, y2. I'm going to use 10 and 10. right? Vibes it up a little bit, right? There we go. What's y2? 11 minus over minus. So don't matter what the coordinates are for the first one, don't matter what the coordinates are for the second one, we go and get the same thing, right? Okay? Or don't do something else, or you go to 10 and 10 and 11 and 11. So M will be equal to what? M is equal to shown, a little box to indicate that it was shown. Wait, box turn way. Right, this box means you showed it. Anything that asks you to show, when you're done show it, put a little box at the end. Cool? There we go. So we go in. Shade the region which is described as y is greater than or equal to x plus 2. Now, if they want you to shade the region, right, which is y is greater than x plus 2. So I'm going up to the graph, right? Y being greater than x plus 2. So if you have a coordinate, right, we're trying to indicate a coordinate where the value of y, no matter what it is, it will be greater than whatever the x value is plus 2. So let me just check our coordinate up here. So if I put a coordinate here, you tell me what the x value and the y value for this coordinate would be here. -1, 3, right? -1, 3. Let me test it now, right? So I'll just put using -1, 3, right? We're going to plug it in here. So this is x, this is y, right? Y is 3, is greater than or equal to -1 plus 2. -1 plus 2 is what? Is 1, right? And 3 is greater than 1? Huh? Yes, right? So therefore, y is greater than or equal to x plus 2. I'm going back up now, right? So if I were to shade the region where y is greater than x plus 2, it will actually be everything above here. Right? So I'm just shading it. This whole region above here will be y is greater than x plus 2. It's above the line. Okay?
Quadratic is basically the same thing.
Yeah.
Straight line.
You're correct. You're very correct. Everybody seen it? I just find a coordinate above the line y is equal to x plus 2. It's a coordinate above the line. I just test it to make sure, and it works. So that means everything above that line would be y is greater than or equal to x plus 2. Everybody good there?
And then they also gave us a line where y is equal to x plus 2. So
right.
From there go up.
Right. So you can look at it. So I was going to tell all of that, but I want to show it, right? So if you have a line and we talk about greater than, it will be above the line, right? Greater than is above, and so greater than will be above the line. Less than will be below. Cool? So watch the next part. This is linear programming, right? Watch the heights here in this next one. They said to write 3 inequalities that define the shaded region. S shown in the diagram above. So let me lock in, right? We wanted 3 inequalities. This is linear programming. This is linear programming, right? 3 inequalities that define this shaded region. So let me work, right? Let me start with line 1. Is it above line 1 or is it below line 1? So that will be less than or equal to, right? So I'm going to write over the same equation, although don't frighten if you ain't catch it too much. All right, over the same equation, but instead of putting an equal sign, I'm going to put less than or equal to, right? So watch it. The first inequality, so y is less than or equal to x plus 2. That's inequality number 1, right? Inequality number 2. Let's go to the line y is equal to x, which is this line. Is it above y is equal to x or is it below y is equal to x? This is the line y is equal to x, right? Is the shaded region above this line or is it below this line? So we use greater than or equal to instead of the equal sign. So we go down. Your second inequality would be y is greater than or equal to x. All with me so far? This is what, all right, let me go back. We go back up. I know all of that get lost, eh? Write three inequalities that define the shaded region, right? Okay? Meaning we want three inequalities that basically define where that shaded region is with respect to the lines. So each line you have, the equation for each line, you cannot write it as the equation, you have to write it as an inequality. An inequality meaning that it have less than or equal to, greater than or equal to, less than or greater than, right? But we use the less than or equal to because it's starting from the line. Okay? So I'll go back up. So I want to know where is this triangle with respect to the three lines. So you're taking one line at a time. So we deal with the line x, y is equal to x plus 2. Is this shaded region above the line or is it below the line? Huh? Below meaning less than or equal to, above meaning greater than or equal to, right? So above or below? Below. So for this equation here, instead of writing equal, you write less than or equal to, right? Then for this line now, is it above, is this shaded region we're talking about, right? Is it above the line y is equal to x or is it below the line? It is? No, we're on this line now, line 2. Is the shaded region above line? It's above, right? So instead of putting equal, you put greater than or equal to, right? Next line, line 3. Is it above line 3 or is it below line 3? Line 3. So instead of putting equal, you put less than or equal to, right? So that there would be a final inequality. It's three inequalities they ask for, right? You see, the great thing about this is how that I should have never have this on this worksheet. Even though it's a coordinate geometry question, it should have been on the linear programming worksheet.
See, we have a 3 lines, right? And then we count this more around 3 inequalities.
Yeah, like if you have 4 lines bound in it, like say it's a quadrilateral, this form a triangle, right? Which is 3 sides, so it will be 3 inequalities.
Yeah.
If it's a quadrilateral that the shaded region forms, it will be 4 lines. 4 lines bound in it. Right?
But how to get 4 lines to that?
Yeah. Everybody good there? I know this a little harder. Okay? But let's hold on, or we'll do that again. I might do it for vacation though, that we might do this probably like in September. If what? Nah. If a line cuts it through the shaded region, it might have a new shaded region that doesn't include what probably is to the left or to the right of the line that I'm talking about, right? So don't fight up with this too much. Anybody wants it to write? All right. Let me go with the last part. Write the equation of the straight line which is perpendicular to line 1 and passes through the origin, right? So they said it passes through the origin. So did they give us a point on the line? Who remember what the origin means? 0, 0. Nice. Right? So parallel note, origin means 0, 0. Right? Cool? That's what the origin means. So this is actually your x1 and your y1. Right? So they said it is perpendicular to which line? Right? So whatever is the gradient of line 1, I need to flip it and multiply it by perpendicular to line 1. If you want the gradient of this line, you have to flip the original gradient and multiply by -1. So we go now. This is line 1. What's the gradient of this line? We spoke about this. Y is equal to x plus 2. What's the gradient of this line? 1. Right? It's the number that is understood in front x here, so it is 1. Cool? So 1 is like 1 over 1. If you flip 1 over 1, it will still be 1. Right? So watch it. The new gradient, I put it right there. The new gradient would be, is like 1 over 1 still 1 multiplied by -1. So my new gradient would be, you have your gradient, you have a point on the line, right? What is the formula to find the form for the equation of a line? Come on, we say it enough. Y minus raise your hand if you remember this formula.
Nah, you remember that easily formula.
So let me go. It will be y minus, what is y1?
0.
What is m?
-1. 0.
So I need to get rid of. Well, y minus 0 is just y, right? And then -1 by x will be -1x or just -x. And -1 by 0 is, so I don't need to put that. So the equation of the line that is perpendicular to y is equal to x plus 2 would be y is equal to -x. Right? That's my equation there. So copy down what I need to copy down, and then we'll go on to recording. So the coordinates of P would be 0, 3, because P is on the y-axis. So the value of x will be 0, and the value of y will be the point that it is on, right? For Q, the value of x will be -2, and the value of y would be 0. So that's your P, that's your Q. I'm going to write it in on it here. So for part A, P would be 0, 3, and Q would be -2, 0. Daryl, this is what? This is x what? Y, x, y. Let's work, guys. Let's work this thing. Okay, determine the gradient of the line segment PQ. Can somebody belt out what my gradient formula is? I'll do it. Like music to my ears, right? x2 minus x1, right? That is my formula. Look, everything done already written out for us above here. Daryl give us was x1 was y1, right? Etc. Right? So there we go. So this will be equal to, what is y2?
0.
Minus 3. This is 1, right? 0 minus 3 over
-2 minus 0.
Excellent. So it'll be -3 divided by -2, right? -3 over -2, leave it as a negative divided by negative is a positive, but we're leaving it as 3 over 2. Because we don't know if we had to deal with any inverse or anything, and we had to flip it and multiply by -1. Cool? Right? So that is M. That is part B. They want the equation of the line segment PQ, right? So to find the equation of the line, my children, I must have the gradient, which I do have, and I must have a point on the line. So you could use either P or you could use Q. Either one. We'll just use P, right? 0, 3. This is my x1, this is my y1. What is the formula to find the form for the equation of a line? Let me hear you. I hear no, thank you, right? X minus x1, right? So let me work. We have everything right here. These questions is the same thing over and over. We do it, same thing over and over. Y1, what's y1?
3.
What is M? Where we getting negative from? What is x1?
0.
What we wait first thing we have to do here, get rid of the, and what we do is -3. Show they one time, right? So y is equal to 3 over 2 by x is 3 over 2x. 3 over 2 multiplied by -0, well, that's 0, so we don't even put that. Plus 3, excellent. That's the equation of my line there. Y Make sure it is always in the form. Daryl, you now come in the class. Make sure it's always in the form y is equal to mx plus c. You see that there? Y is equal to mx plus c is the equation of a line, right? This is the form for the equation.
So, like, oh, you're recording it there, right? You just sent the new.
Yeah.
That's really cool.
So now I'm trying to pause so the file won't be too big.
Yeah.
And this is the formula. Yeah? This is the formula to find form. Put these little things down. Write them in red if you could. Right? So copy them down. Right. So the point -8 comma t lies on the line segment PQ. Determine the value of t. Right? 8 comma t is what they want. They wanted to find t. So look at this, right? This was what, boy? This was B, C, right? So we wanted D. Right. So look at this, okay? Oh, I don't want red. Right. So they gave us the coordinate as -8 comma t, right? How do we use the equation of a line, right? So we have the equation, right? So the equation would be, what was? Y is equal to, what's the equation of the line? 3 over 2x add 3. How do we use the equation to find an unknown value or unknown part of the coordinate? So this is your x value and this is your y value, right? How do we use your equation to find the unknown? You simply substitute it in, right? So I'm going to put when x is equal to -8 and y, what is y equal to? T, right? We're plugging it into the equation now, right? We're going to have, instead of y, I'm going to put t equals 3 over x. Instead of x, what do I put? I put 3 over 3. 3 over 2. Instead of x, what do I put? Excellent. Plus, so when we work out t, what we get t to be? -12. So any second now. Anybody work it out? Well, I ain't sure if anybody reach here. Right? -12. Yuvraj, you get this? That's how you use the equation of your line. Oh, -12 add 3. May I say that the answer? How we get t is equal to -9. Right? You see how we just use the equation there?
Just how you
Talk.
-8 plus 3.
No, you're multiplying 3 over 2 by -8. 2 into -8 is -4. Now, you gotta work out this first. You get -12. -12 plus 3 is -9. Everybody good there? You all need to copy. The part we are doing is part D. We're trying to find the equation of the line AP, which is perpendicular to PQ, right? We have a coordinate on the line, which is 6, 2, and we have the gradient of PQ, right? So I wrote down 6, 2, and I took the gradient of PQ, which was 3 over 2. I flip it, multiply by -1, I get my new gradient, right? So what is the formula to find the form for the equation of a line? Y minus is equal to, everybody remember this?
Yes.
Stick that on the head, you know? Right?
Whole class we do it, but we forget it.
Wait, a little bit surprised, yes? A little bit surprised. Right, we good there, right? Okay? Y minus what? Is equal to by minus. We good there? We getting rid of the? Right, let me go. And what we doing is -2. Fling that across there, right? Let me go. Y is equal to?
-4.
Minus, no, plus 4. A negative multiplied by a negative is a positive, and then 2/3 multiplied by 6 will give you 4.
It would be 8 actually then. When you bring the
3.
negative 2 to that side, it becomes positive 2.
Right, this will be positive 2.
Then what's going on?
2/3 multiplied by 6, right? 2/3 multiplied by 6 is 4, right? Right, so there you go. Y would be equal to 2 over 3x plus 6. Proper thing here, right? Everybody good? Talk, eh? We move in. Right, what's the coordinates of A and B? Come on, quickly. Coordinates of A and B. Quickly.
So B is 6, 0, and A is -1, 0.
Kyle and Tristan, lock in. A is -2, 3, and B. What's B? Daryl, you good there? You sure you understand how we get them thing, Daryl? Daryl, watch it. A. You see A here, Daryl? What A line up with on the x-axis? What A line up with on the y-axis? Shania, good there? What A, what B lining up with on the x-axis, Shania? You can see that 4, right? And B lining up with 6. That's where I get them coordinates from. Miriam, you good here? I realize you're functioning, right? Right, there we go. Gradient, come on, Arnold. This is food. This question is food. Gradient, come on. What's my formula for gradient? Somebody belt it out. M is equal to 2 minus y1 over, right? I need to put the little x1 and thing above here. Huh? X1, y1, x2, y2. I don't really need to put it, but let me work. Right? Right. Call them out for me, quick.
6 minus 3 over 4 add 2.
4 minus -2. We go put the add after, right? 6 minus 3.
It will be 3 over 6 by the half.
3 over 6, which is a half, right? Right, that's common M. Let me see the accent for next. The equation of the line which passes through A and B. Simple thing, equation of the line, right? What is the formula to find the form? Or let's stick this in all your brain, please. What's the formula to find the form for the equation of a line? Y minus is equal to x minus, right? Let's go. Y minus, what y1 was above? 3, and we're using 3 and -2 and the gradient right here. Right, so 3 is equal to a half by x minus -2, right? So this becomes a positive, right? Don't forget that. Right, there we go. We're multiplying into the brackets, and then we throw -3 on that side one time, right? Right? So -3 going there too. So there we go. Y is equal to a half. You've had your grandfather picking you up today. Right, let go. A half x. A half by 2 is what? 1. Right? And then -3 becomes. So my equation is y is equal to a half x plus 4. Although copy it down in the video now. Let me try to see if you can eat it up. Right. The equation of a straight line is just 2 more questions. The equation of a straight line, but we are real time. Right. The equation of a straight line is given by 3y plus 2x minus 6. Now this is very important, because right to 2x plus 6, right? So listen to what I'm saying. They asking us the gradient of the line. What's the gradient of the line here? Huh? 2/3. Excellent. All right. So I'm going to write down the equation of the line. 3y is equal to 2x minus 6. Is this equation in the form y is equal to mx plus c? No, because it have a 3 in front of y. We need to move that 3. When you carry that 3 on this side, you actually have to divide it by everything there, right? So watch. We're going to write it so first, and then I'll show you, all right? So y will be equal to 2x minus 6 all over 3, which means that this 3 must be divided into the 2x and into the 6, right? So y will be equal to 2 over 3x minus 6 over 3. Everybody with me so far?
Yes.
Right. So y will be equals to 2/3 x minus 2. That is the equation of your line. In the form y is equal to mx plus c. So I can now say, therefore, therefore, y is equal to mx plus c. What is m? What is m? Y is equal to mx plus c, right? What is m? 2/3, right? We couldn't use the formula here because we didn't have 2 points on the line. We did not have 2 points on the line, right, Shana? Didn't have 2 points. So you must write it in this form. Okay? Cool? We go now again. So they said the equation of the line is perpendicular, the equation of the line which is perpendicular to this and passes through this point. They want the equation of that line, right? So let me see what the brain is, right? In order to find the equation of the perpendicular line, right? We must have a point on the line. Did CSEC give us a point on the line? 4, 7, boom. You'll see that CSEC gave us that, right? This will be a x1, this will be a y1. How do we find the gradient of this a line perpendicular to the equation we had above? What we need to do? You flip the original gradient, which was what? 2/3 becomes 3 over 2 multiplied by -1. So your new gradient would be -3 over 2, right? So we have the gradient of the line. We have a point on the line. What is the formula to find the form for the equation of a line? Only hear one man talking, you know. Well, you remember that by now? That's the formula to find the form, right? So what would be y minus what?
-3 over 2. 4.
I don't know for listeners, the same thing we do over and over and over.
Yes.
It's just the same thing we do over and over and over. Watch. And this is CXC questions from the past 10 years. This is the past 10 years. And this is how the questions come in. It's the same thing every year. No? Right? So there we go. So y is equal to -3 over 2x. -3 over 2 by -4 would be what? Positive what? Positive 6. And when -7 comes on this side, what becomes? So y will be equal to -3 over 2x plus 13. Everybody good there? That is the equation of that line, right? Last question, right time. Right, we have 13 minutes. All right, this was the hardest question, I remember, right? So all you're going to take 5 minutes to do it, and then I go run it. Right? Number 11, try something. We pause here. Watch that. Right. So the first thing they want us to do is to find the value of C. C is your y-intercept. So your line is cutting the y-axis at 7. So you simply put C. So all you put here is C is equal to 7. Right? Now they want the gradient of the line. So we have to do a little working now. Right? So let me get 2 coordinates on this line now, Daryl. What's the coordinates of A, Daryl? A, let me write it here. What's the coordinates of A? What's the x-axis value? What this point here, A, watch it good, eh? What this point here, A, lining up with on the x-axis? 0, comma, what's the y value? 7. What's B? Ooh. What's B earlier?
2, 0.
2, comma, 0. Excellent. Come on, we finishing it.
Not breathing me out the breathing.
Here's 2, right? This is 2. Okay? 2, comma, 0. There we go. We can work now. I see that I'll split up some people next week, buddy.
Wait,
See that I'll split up some people next week.
now we.
0, 7,
I don't know.
0, 7, and 2, 0. X1, Y1 is all yourself are talking about, you know? X2, Y2. Right, let me go. Daryl, what's my formula for equation of not equation, sorry, this is gradient. Daryl, what's my formula? Common M, Common M is equal to what, Daryl? Gradient. Y2 minus over minus X1, right?
So it should be now.
Where were? T? Where D gone? Can I think that's this way? Now we find it. I was lost, but now I'm found. I know what's going on. Wait. There's some party somewhere.
So your neighbor told you the bathroom.
Downstairs after that or that song like next door. Yeah. Them always like, man. I got them luxuries, huh? I mean, some people with money.
They're probably retired and just.
Probably them enjoying life.
You should be safe.
Hey, come now. Again, all the thing at the artillery here. Hey, class supposed to done now, no? Yeah, come now. Let's do this one now. Let's do the rest of homework. What's the answer here? 0 minus 7 over 2 minus 0, which should be negative 7 over 2. What would that be? All right, let's leave it as negative 7 over 2. I'll finish out this homework now. I'll send in this in the group, right? I'll get one little thing to do for homework, right? HWs.